Hi everyone, so welcome to the second tutorial for automated electron microscopy, and in this tutorial we'll cover how you can script with AutoScript on a personal laptop. So it's just not about the last tutorial I showed you how you can install in your desktop PC and do scripting from there, but today it's very handy when you can also script from your personal laptop, write some code beforehand and go on the microscope and try that, right? So before moving forward, I would like to take this opportunity to thank my teammates at the UTK, my advisor Gerduser and Sergey Kalinin, and our Thermo Fisher collaborators Paulo Longo and Remco Goetz. And the agenda is first we will update to a new AutoScript version. So recently I checked that they released the 1.15 version. So first we'll do that, and then we will set up acquisition for AS from your personal laptop, and we will run the same example of scripting using the simulator, and then we'll also do a little bit of live microscopy scripting today. So let's first jump into the part one to update the AutoScript version. So first we will come to this link, this portal for software updates on Thermo Fisher, and then we go down and we select the AutoScript TM. And if you go down, it says that it released the new version 1.15 in October, and currently let me check what AutoScript version I have. The version 1.14, as you can see here, right? So we would want to update it. So let us download it. So to download it, we first need to log in. And now we can download that. So meantime, when it downloads, you can see that the release information here, where they have added like the 4D stem with CETA functionality. That's great. They also have multi-else acquisition for the Iliad microscope that they have, and there's some control of frequency for the nanopulsar. You can see here there is also a link to AutoScript team examples scripts. If we take a look at that, yes, so you can download these examples as well. Anyway, let's go back to, yeah, still there's some time until it downloads. So here are two options, update and uninstall. So we need to update it. Let's go for that. Now we can choose to either restart the computer or you can restart it later as well. For now, I think it's okay. You can just keep it, unless if you face issues with how it is functioning, you can restart it. Finish it. Now we can see, let's open it again. Now you see it has been upgraded. It's now color, it says 1.15.0.484 version. It's the offline mode right now, so now let's come to part two, where we have updated the AutoScript version, but now we want to run it on our personal laptop. Awesome. So now let's go to the next part where we want to get the files for running it on a laptop, right? So for that, we need to first go to the local disk C, and we need to get the Python modules where it installed. So you can find those once you go to program files and under thermoscientific AutoScript TM in your local disk C. And if you go to Python packages, you can see all the build files here. Let me zoom in. And what I will do is I will take these files, put it in my pen drive, and then put it in my personal laptop so I can install these on that and then can do remote acquisition from my laptop. Everyone, now we will go to this folder tutorial 2, and as you can see here, I have put all the files that I copied from my Windows PC from the local disk C partition for all these wheels that I showed you earlier. And now let us get it installed. So we open Visual Studio Code, and we go to that folder. Yeah, that should be good. Those who are not familiar with VS Code, you can use any sort of even a Jupyter server or PyCharm or anything else. Let me check if view is good. Okay, this should be fine. Now I first want to set up a Python virtual environment. So for that you can use, there are multiple methods. You can use conda. So you can go to Anaconda and set up your virtual environment, right? There's all other ways, like you can use pip directly, but I'm going to use these UV to set up the Python environment. Okay, so I have already installed it. In case if you are on MacBook, you can install it using brew. You can have a guide how you should install the software getting started, and for different system. I'm on Mac OS, so it already read that, and there's also the Windows option, and I already have UV. So let me do initialize pair. So when you do that, you can see it makes a small project toml file, tells you about the Python version. You can change it if you want to have some other version. So now we can add basic packages like UV add numpy, and we can also add UV add say matplotlib. We can also add say pandas. Now let us go and check it. So here is the virtual environment that it creates, and let's install these packages. So for that, let us go to Python packages, and we can do UV add AutoScript core, and the moment we add that, did install that, and let's do UV add AutoScript TM microscope client tests, and it says that the request does not satisfy Python greater. So as you can see, it asks for greater than 1 so let us change that and try to add it again. Now it has been added, and after the test we have the client. So that has been added as well. Let's do the snippets. That is also added. Toolkit. And finally, let us add the logging module. So all this has been added, and you can go here and you can also check it. Look, here they are installed. Now we need to also, there is also requirements.txt file that we can check. So these are the dependencies that AutoScript wants us to install, and at the bottom you can directly see that we installed these 6 of the packages from them. So let us get these as well. So pretty easy now that we can do uv add below, and you can say it added that. Numpy we already added. Let's do colorama. So that is added. Add OpenCV Python. So that has been added. UV add AlexML, and then diffused XML, H5P5. PyTest and PySite 6. Awesome. Take some time to build. Awesome. Now we have all this already. And if we want to run the code in a Jupyter notebook, so we should also install uv add ipy kernel. So that has been added now. And now once we set up the environment, I have quickly written a tutorial notebook. It is the same code that I introduced in the previous tutorial. If you have not taken a look, you can find it here. I'll put the link in the description. So basically this part of the code, which we already tested on the same computer, but not on the personal PC, right? Personal laptop. So I have basically imported those here, and let us try to run this. Now we have installed all the packages in this environment, and ideally you can choose it by going through your Python environments, and this one is mine where I installed everything. And the way the UV works is, you can see the Python name is environment is always .venv, but it is same as the folder which is the parent directory. That's how you can find the environment. And then let us put this guy down, as we don't need it. Let us import these packages. And now once I have imported that, this should not work, right? Because as you can see, the IP is my local host, and this particular laptop, the local host for it is itself, and it cannot see the Windows PC on which I installed a microscope. the AutoScript. So now I am back on my Windows PC and I want to know my IP address. So I type ipconfig in PowerShell, and here is the IP address. Now I enter the IP address and you can see that it is connected, and the port by default is 7521 here. If you want to put in a port, say you ran it in 9095, you can mention that here as well, and you can just put there and it will connect that. And this is the old script to convert it to the STEM mode. And we can also read out some microscope type and software version, and it is the offline version, right? So that it displays. We'll also look at when we connect to the live microscope what it says. Then let us read out available detectors and cameras. So it says the CETA detector, the Falcon, the FluCam to read the screen current, and it also displays MPEG. And for scanning detectors, we have this dark field and bright field detectors on the simulator. And now let us just grab an image from the HADF with 1000 resolution with 50 nanoamps of 15 nanoseconds of exposure. And you can see that it grabs an image from the HADF that we already see, but the key point here is that we are now running on a personal laptop, right? And you can also get the CETA, and that's the highlight, right? When you're working on your personal laptop, if you're not doing heavy machine learning or lifting, you can run the code directly, and that is very convenient. And now let's get to the part where we connect to the actual microscope. So for that, I will first have to connect to my VPN of my university, and let me enter that. Yes. And it sends me a confirmation code. Let me accept that. Device, and I am connected here. Now once I'm connected, I can now change the IP address to my actual PC IP address, and the IP address on my actual microscope is different, so I changed that one. And now let me connect to it, and once I connect to it, I think we can query what is the mode of the instrument. This is in STEM mode. We can also check now before changing anything that what is the state of the vacuum. It is ready, and is the column valves opened or that state, and it is closed right now. So let's open it quickly. And so I opened it now, and if I check the state, it's open, right? We don't need to do this one. Now we can check the microscope type and software version. So you can see it says Titan and some version details. And let's list out the detector and cameras on this microscope. So you have a CETA camera, a flu cam detector, energy filter CCD, and we have this scanning detectors. And now once we have that, let us get an image. Now I'm not sure what is the state of the microscope right now with where is the sample. I would expect the sample to be in the I assume that I don't need to move the stage a little, and I don't have access to the microscope right now. It's in the university and nobody is using that I confirm. And let us see what is the image that we get. Ooh, so these are the gold nanoparticles. The height needs to be changed a little. But yeah, that we got. Can also get a diffraction pattern on the CETA, but let us keep that for the next tutorial where we do more advanced stuff. So that's it. I will upload these files. This tutorial notebook is same as you can on this Medium tutorial, so go ahead and run that, and thank you for listening.